Assalamu alaikum warahmatullahi wabarakatuh. Welcome back, dear students, to chemical equations. I think you must have gone through part one, and if you have understood those basics, then this part two will become very simple for you. Hope you are enjoying doing these chemical equations and solve as many equations as possible and see how well you can balance them. So let's start with. Okay. So as we have seen that it's the matter is in three forms, that is solid, liquid and gaseous. So we are going to check how does the chemical change takes place. If you see, whenever you are adding two substances, it reacts, and there can be a two type of changes, that is temporary change, permanent change, natural change and man-made change. And this is the physical change what he's stretching and showing, which can come back. And there are different categories, and chemical change which is irreversible, the reaction taking place during the occurrences of, like if you look at coal burning, digestion of the food, iron nail, once it is exposed to a humid atmosphere a long time, you see it getting rusted. So these are certain types of the changes which we see. And respiration, milk getting converted to curd. So these are irreversible changes. Once the milk is got converted to curd, you cannot make it convert it back to milk. And lime water experiment is where very often you have seen how the lime water works with. So you have even seen how does lime water changes, when you are passing carbon dioxide gas into lime water, it turns milky. So that is also one of the example of the chemical reactions. And this crackers burnt, these are all the chemical reactions. If you take 1 gram of quick lime in a beaker and add water to it, and whenever water is added, and you touch the beaker with your finger, you find the beaker hot. So as you all know that when the beaker is becoming hot, that means it is an exothermic reaction. Energy is released here. Heat is released. So the reason is that calcium oxide reacts with water and heat energy gets released. So calcium, if you have seen, in your house anywhere, whenever there is a whitewashing that's been happening, you can see that lime is mixed with water for whitewashing. So at that time, you see a lot of heat energy being exhausted out of it, out of the lime, which is being used for whitewashing. So, dip a red litmus, and when you are dipping a red litmus paper into it, it turns blue. So that means it's a basic solution. As you know, if the red litmus paper, if blue litmus paper turns red, that means it's acidic. Whereas red litmus, if it turns blue, that means it's a basic solution. So let us do an activity to see what we can do is, if we are taking 100 ml of water and we are dissolving sodium sulfate in it. And this we are mixing it well, and another 10 ml of water we are adding to the same beaker, and then we are adding barium chloride to it. So now we are dissolving it. First we make an aqueous solution of sodium sulfate, then barium chloride, and when we have added both the solutions, both these aqueous solutions were added, and we found a barium sulfate precipitate was formed in a solid form. So what's happening here, when you take sodium sulfate plus barium chloride, it gave rise to barium sulfate and 2 molecules of sodium chloride. So, and you take zinc. Another example is zinc granules are taken in a conical flask and hydrochloric acid is added to it. And then you see a gas that is being released. You observe a gas getting released from the conical flask. And when you are keeping a burning flame over it, the flame stops with a pop sound. And whenever it stops with the pop sound, you all know that the gas released is nothing but hydrogen. Hydrogen gas has been released. Then only you will get that pop sound. If it would have been oxygen, it would have allowed the flame to burn. And so this reaction produces heat again. So again, it's a exothermic reaction. Now calcium oxide reacts with water into a new substance, and it either form calcium oxide or water. So the description of this chemical reaction is quite, reaction in a sentence of this activity could be quite long. But if you just look at this, what is happening is calcium oxide and water, if you're writing a chemical equation, gives rise to calcium hydroxide. That is what, if you learn these chemical equations very well, there are chances of you scoring 100% marks. It's simple like your maths. You do an problem and get 100% marks. You don't have to write pages together like you were writing modern periodic table, Mendeleev's limitations of the Mendeleev's periodic table. They are lengthy answers. But whereas in chemical reactions, what is happening, the whole experiment, what you are doing in a laboratory, can be explained through these simple equations. Like here we see that calcium oxide is a reactant and calcium hydroxide is a product. So when calcium oxide has reacted with water, it gave rise to a substance called calcium hydroxide. So hydrogen atoms of water reacted with calcium, forming hydrogen, calcium hydroxide. So thus what are we going to see is, whenever when you are writing a chemical equation, you write it like this, generally. How are we doing it? You see that one water compound, it is made up of one atom of oxygen and two atoms of hydrogen, and then a nitrogen element. Or these are the symbols that list one carbon element is also there. So what are we doing is calcium oxide and water. These together, when they are mixed together, the product that we are getting is calcium hydroxide. And a gas that is liberated out is hydrogen gas. Okay. So now you can see it, how calcium oxide reacts with water and gives rise to calcium hydroxide. So now just see whether this equation is balanced or not. What have we done is one atom of calcium and oxygen. When it has reacted with hydrogen, it gave rise to calcium hydroxide two times. Two. So that means calcium, one molecule, yes, agreed, one molecule of calcium, and oxygens are how many? One in calcium oxide and one in water. So there are two oxygens in reactants. So we should get two oxygens in products also. So yes, we are getting two oxygens in the products. When you say OH two times, when it is written outside the bracket, whatever are the elements present inside the bracket will have the value given outside the bracket. So two, that means two hydrogens and two oxygens. So here also we have got two hydrogens in reactant, and product also we got two hydrogens. We have got two oxygens in the reactants and two oxygens in the products, and one element of calcium in the reactants and one element of calcium in the product. That means it's a very well balanced equation. Most of the students make a mistake. They think that if there are two reactants, the reactants, to balance the equation, even the products have to be two. There is no need that always you should get two products. Sometimes you will get only one product, but what you have to see is the total number of elements must be equal on both the sides. That is what is called as a balanced equation. So, and we use an arrow in between to show whenever we are seeing what product is formed, we use an arrow. Now, zinc metal is reacting with a dilute hydrochloric acid to yield zinc chloride, and in this reaction, a gas that is liberated is hydrogen gas. So you see how this reaction is taking place. Zinc, when it combines with hydrochloric acid, it gives rise to zinc chloride plus hydrogen gas. So now let's balance this equation and see whether it's a balanced equation. In this, what are we doing is we are taking one element of zinc and one hydrochloric acid, and this is giving us zinc chloride plus hydrogen. So now, is this a balanced equation? It's not a balanced equation. Why? Because, okay, zinc is balanced. You get zinc here in the reactants, and one molecule of zinc in the reactants, and one molecule of zinc in the products also. Whereas hydrogen is one in reactants, whereas two hydrogen gas is liberated in the form of H2. And then you find one chlorine in the reactants, whereas zinc has got the combining capacity of 2 in its outermost shell. So chlorine, it combines with chlorine, forming ZnCl2. So this is not a balanced equation. Then if this is given and you have to balance, how will you balance this equation? So let us see how are we going to balance this equation. And sodium sulfate reacts with barium chloride to give precipitate, that is barium sulfate is formed. And you see how sodium sulfate plus barium chloride combine together to give rise to barium sulfate and sodium chloride. So now let us see how can we balance. Are these balanced equations? If they are not, then we have to balance them. So you have to understand this common funda that mass can neither be created nor be destroyed. So whenever the reaction takes place, the total number of molecules that are combining to form a product should be equal in both the sides. Okay. So that is in a balance. When you're keeping the reactants on one side and the products on one side, they both have to balance. Then only you will be able to prove the law of conservation of mass, which says that mass can neither be created nor be destroyed. Okay. So let's see how is it happening. Now you see the smallest particle of the element that takes part in the chemical reaction, that is the outermost electrons in the outermost shell. How are they taking part in and what happens to its mass? If you look at carbon dioxide, carbon and two molecules of oxygen forms carbon dioxide. And all the chemical equations must balance because atoms are neither created nor destroyed in a chemical reaction. So if you look at it, carbon plus two molecules of oxygen gives rise to carbon dioxide. And if you see hydrogen, a chemical equation in the number of atoms of different elements on the reactant sides are same as those on the product side, and then only we call it as a balanced equation. Now if you see 1 unit of hydrogen, the mass is 1 unit, give rise to 2 H2, that means 2 masses units of hydrogen. One hydrogen, when they unite together and H2 is formed, the mass has to be doubled. Now if you look at sodium chloride, sodium and chlorine ion, when they are combining together in an ionic, it's one of the example of a strong ionic band. And similarly magnesium and bromide ions, when they combine together and give rise to one molecule of water. So what is actually happening in H2O bound? You see, as oxygen has got 2 electrons in its outermost shell, it can combine with 2 hydrogens, forming a strong water bound, forming a product called water. So you see how hydrogen is reacting in this. So let us see in step 1, what are we going to do is, we are taking calcium oxide and we have added, as I told you, lime. Lime is nothing but calcium and water added together. जो आप चुन्ना डालते हैं घर पे है ना, you say whitewashing. So उसमें what are we doing? Calcium hydroxide is nothing but lime. So calcium oxide plus water, when it is added, it is giving rise to calcium hydroxide. So what is happening here is, we have taken 1 atom of calcium and oxygen. This I have shown you, it's quite a balanced reaction. Now in the step 1, we have seen that how it is yielding and reactants. Repeating again. See this. Now, if you take two molecules of hydrogen, which is combining with the two molecules of oxygen. So now let us see how many atoms are there. On the left-hand side is your reactants and right-hand side is your products. So how many hydrogen elements do you see on the right? Left-hand side is 2 and right-hand side is also 2. And whereas elements on the left hand side, oxygen is 2, on right hand side is 1. So that means oxygen is not balanced. So what do we have to do to balance this? So in step 2, we have to see that 2H2O plus O2 give rise to 2H2O. So now what have we done? We have balanced the equation. How did we balance it? We have taken two molecules of hydrogen and one molecule of oxygen, and when we have combined together it has given rise to 2H2O. And what you have to do is, if this is written on the left side 2H2O, so total number of hydrogen atoms are 4. You have to multiply with this. 2 into 2 is 4. And here, because nothing is written here, that means by default it's only 1. So these are only 2. So oxygens are 2 and hydrogen are 4. So when you see here, you see the same ratio. 2's are 4 hydrogens, and this 2 is multiplied with oxygen and giving 2 oxygen molecules. So that means this is a balanced equation. And now let's see the above equation 2 before the molecular formula of hydrogen and also 2 before the molecular formula of water. So that is how we have to add 2 wherever it is necessary and make sure that the equation gets balanced. Now you observe an atom on both the elements, hydrogen and oxygen, are same or different or on the both the sides. Now we are taking two molecules of hydrogen and one molecule of oxygen and 2H2O. In the third step, let us see whether it is balanced or not in this case. When we have taken two hydrogens and one molecule of oxygen, give rise to water. So this needs no division of coefficients of the substance. It's the lowest ratio, water. So that is the reason we use water example all the time, to show that it becomes very easy for you to understand. So finally, in the fourth step, what have we done? 2H2 plus O2, now 2H2O, and it has become a balanced equation. So now let us see what happens in propane gas. Propane gas, you know, it's a gas which is used as a fuel. So C3H8 is the colorless, odorless gas. So let us see the chemical combination H8. In this, 3 molecules of water and 8 molecules of hydrogen combines together to form propane gas. So let us see the reaction of propane in oxygen when it is burning. So propane and oxygen, when it burned, it gave rise to the products called 3 molecules of carbon dioxide and 4 molecules of water. Let us see, is it a balanced equation? Is the equation balanced or not? So here you can see on the left side we have got 3 molecules of carbon. Do we have 3 molecules of carbon on the right side? Yes, we do have 3 molecules of carbons. Okay, and now we have got hydrogen, 8 molecules of hydrogen on the left side. Let us see how many hydrogens are there on the left side. 4 to the 8, right side. So even in the products we have got 8 hydrogens. And then how many oxygens do we have? 5 to the 10 oxygen. So on even in the product side, we need to have 10 oxygens. So do we have? Yes, 3 to the 6 oxygen plus 4 oxygen here. This 4 is multiplied here 1 time, so 4. So 6 4s are 10. Here also 10. That means this is propane, when combines with oxygen, give rise to 3 molecules of carbon dioxide and 4 molecules of water. Is a balanced equation because we see all the reactants left hand side and the right hand side as balanced reaction. Let us see. Will it be shown as a reaction? So what are we doing in step 1? We are taking propane plus oxygen, giving rise to carbon dioxide plus water. So now in this reaction, what have we done is propane is C3H8 plus oxygen. This gives rise to carbon dioxide plus water. So is this a balanced equation? So here, how many molecules of carbon are there? There are 3 molecules of carbon in reactants. Okay, in the left hand side, either it is left hand side or reactants is one and same, right hand side and product is one and the same. Either you can call it products or right hand side elements, or reactants or left hand side elements. So now, because our left hand side elements, reactants, are having 3 carbons, even products should have 3 carbons, but here we find only 1 carbon. Okay, so carbon is not balanced here. And then when you see with hydrogen, in reactants we have got 8 hydrogen, whereas in products we have got 2 hydrogen. That means even hydrogen is not balanced. Whereas oxygen, we have got 2 oxygen in reactants and 3 oxygen in products. So this is not a balanced equation. So let us see stepwise how we are going to balance this equation. So chemical equation, this the one which you have seen, the unbalanced equation, where the reactants and products were not balanced, we just call it an skeleton equation. So that was an skeleton equation. We are going to make it a balanced equation. Let us see how we can do it. In step 2, we are taking that skeleton equation where C3H8 propane, when combines with oxygen, gives rise to carbon dioxide and water. So the coefficient to balance, what do we have to do to balance the equation? So let's start with the most complex substance. So let's take propane first. So let's look into what all are the elements that are present on left hand side and the right hand side. So what all are the elements that are found? There is carbon, hydrogen and oxygen. So let us take carbon. In left hand side, what do we see? 3, C3H8. So we have got 3 carbons in left hand side, whereas in CO2 only 1 carbon in right hand side. And hydrogens, we find 8 hydrogens on left hand side, whereas only 2 hydrogens on the right hand side. And oxygen, also 2 oxygens on left hand side, and here we find 3 oxygen. So we have to balance carbon, hydrogen and oxygen, all 3 elements here. So let us see what can we do in the third step. So we are always going to, first step we have taken the skeleton. Second step, we have made a table to see these elements on left and right hand side. And now in the next step, what have we done? We are trying to balance this equation. So what did we do? Have we balanced this equation? Yes. If you see, left hand side, we were having 3 carbon atoms. So we added 3 here. So now 3 molecules of carbon on the left hand side and 3 molecules of carbon on the right hand side. Okay, carbon got balanced. But what about hydrogen? We have got 8 hydrogen on left hand side or the reactant side, whereas in the product side we have got 2 hydrogens. So hydrogen is not balanced. And when it comes to oxygen, we have got 2 oxygens on the left hand side, and whereas the 2 3s are 6 plus 7 hydrogens, oxygen on right hand side. So even oxygen is not balanced. So what have we done is we have just balanced. When we're trying to balance this equation and make carbon equal in both reactants and products, we could not set right oxygen and hydrogen. So in third step, what are we going to do is we are going to take one more element now, the number of hydrogen atoms. Let us see how many hydrogen atoms are there in the reactant. In the reactant side, we have got 8 hydrogens, and in the product side, we have got only 2 hydrogens. So what are we going to do is we are going to add 4 more atoms of hydrogen on the right hand side. So now we could balance to hydrogen. What have we done is here we have got 8 hydrogen in the reactants, and in the products also you will find 8, 4 to the 8 hydrogen. Now oxygen. Carbon we could balance and hydrogen we could balance, but oxygen we couldn't balance because oxygen is 2 in reactant side, whereas it is 3 to the 6 plus 4, 10, 10 on the product side. So how are we going to balance to make it 10 here? So we have to take 5 molecules of oxygen in the reactants to balance this equation. So in the next step, how are we going to balance this equation C? Now finally look at the number of oxygen atoms. Now when we look at oxygen atom, we find that oxygen is not balanced. So what do we do? Propane plus 5 molecules of oxygen gives rise to 3 molecules of carbon dioxide plus 4 molecules of water. Now if you see, all the elements are balanced here. 3 carbons in the reactant side, 3 carbons on the product side, 8 hydrogens on the reactant side, and 8 4 to the 8 hydrogens on the product side, and then 10 5 to the 10 oxygen in the reactant side, and here also we see 10 3 to the 6 plus 4 10 oxygens in the product sides. So now you see that propane plus 5 molecules of oxygen gives rise to 3 molecules of carbon dioxide in the form of gas and 4 molecules of water. So now you see that we have taken 2 molecules of propane. There we took 1 molecule of propane. Now we are taking 2 molecules of propane and 10 molecules of oxygen to give rise to 6 molecules of carbon dioxide and 8 molecules of water. So we are taking gases, propane gas and oxygen gas in the reactants, and in the products we are getting carbon dioxide in the form of a gas and liquid water. So gaseous stage in the chemical reaction gave rise to gases and water in a liquid and a gaseous form. So the equation is balanced and the coefficients are not the smallest whole number. So it depends upon, supposing if I wanted to have, if I require 8 molecules of water or 6 molecules of carbon dioxide, I wanted something in this ratio, then I have to take 2 molecules of propane gas and 10 molecules of water to get these reactants, whatever is required. How many quantity, it depends upon the quantity I require. The more the quantity I require, I have to keep on adding the molecules here to add up my products, to increase my the quantity of my products. So the number and the kinds of atoms on both the sides of this equation are one and the same. Now another example we'll take, where we are taking ferric oxide plus aluminium. And when this ferric or iron, when it combines with aluminium, what is happening here is 2 molecules of iron plus 3 molecules of oxygens are combining with 1 molecule of aluminium to give 1 molecule of iron and 2 molecules of aluminum and 3 molecules of oxygen. So is it a balanced equation? Let us see what all are the elements that are balanced and that are not. Here in the reactant side, you have seen 2 molecules of iron or ferrous, whereas in the products, you see only 1 molecule of iron. That means ferrous is not, we could not balance, it's not a balanced equation. And similarly, if you look at oxygen, we are using 3 molecules of oxygen in the reactant side and 3 in the product. So oxygen is balanced here, we need not touch it. So whereas aluminium, we are taking 1 molecule of aluminium in reactants and getting 2 molecules of aluminium in the products. So aluminium has to be balanced. So let us see how can we balance this. Try it out. I think before you get the answer, just think how can you balance this equation. In step 1, we are going to check how to balance this. So we are going to form a table similarly with left and right hand side elements, and let us see how many elements are present on left hand side and how many are present on the right hand side, and see how we can balance them. So this is a skeleton we have got. So let us make it into a balanced equation. So number of atoms in the reactants and number of atoms in the products. So let us see what happens to ferrous or iron. So in reactants, we have got 2 molecules of ferrous, whereas in the products, we have got 1 molecule of iron or ferrous. And oxygen is 3 in the reactants and 3 in the products, so no issues. Oxygen is balanced, whereas aluminium is 1 in the reactants and 2 in the products. So aluminium and iron, both has to be balanced. So how can we balance this skeletal equation? Let us see. So we need to add 2 molecules of iron on the product side and 2 molecules of aluminum in the reactant side. So let us multiply iron by 2 and aluminium by 2 so that we can balance this equation. So now our iron is balanced. If you see, iron is 2, 2 in both reactants and products, whereas aluminium is not balanced. So we have to multiply aluminium also by 2. Whenever you are writing the number 2 on the left hand side, that means you are multiplying it. Okay, so let us add 2 to the aluminium atom on the left hand side and make sure that aluminium also gets balanced. Thus, in step 3, what we have done, we have added aluminium in this on the left hand side, and now it's a balanced equation. 2 molecules of iron on the left side and right side, 3 molecules of oxygen on the left side as well as on the right side, and 2 molecules of aluminum on the left side as well as on the right side. So this is a balanced equation. Hope you all have understood how to do and make a balanced equation. Now the above equation is balanced and the coefficients are also smallest whole numbers. So ferric oxide plus 2 molecules of aluminum give rise to 2 molecules of ferrous or iron plus aluminum oxide, trioxide. So now the number of atoms, aluminium, iron and oxygen on the left hand side as well as on the right hand side are same. You see that in reactants, you have got 2 molecules of iron and 2 in the products. And similarly, 3 molecules of oxygen in the reactants and 3 molecules of oxygen in the products. And 2 molecules of aluminum in the reactants and 2 molecules of aluminum in the products. So if they all, this is to prove that mass can neither be created nor be destroyed. So it has to be balanced, equal, both in reactants and product sides. The above method of balancing is called as, just note this down, this is an important definition. This method of balancing is called as a trial and error method. Okay, so note down this as trial and error method. Note down this, you can stop it and write down the definition, because these are the small definitions you may get in the 1 marks answer. This is trial and error method, and only sometimes to take more care to balance the equations. Okay. Now Let's move on to see how can we get more information now. Till now what were we seeing is total number of molecules we were checking, the characteristics. The chemical equation gives us the characteristics of a element, that is its characteristics is we are looking at physical state and how heat changes, whether it's exothermic or endothermic, or is on what state it is it in a form of a precipitate, or what all are the different aspects which we have, whether gas is evolved, whether it's liberating gas or precipitate is formed. So this is expressed through an equation. When you look at the equation, you should be able to tell whether it is in what state are those elements. What are the states of your reactants and what are the states of your components. Whether your reactants were solid or in a gaseous form, and the products that are formed are maybe in a liquid or a gaseous or a solid form. So only these characteristics may change, but not the total number and the mass. Mass cannot change. Mass will remain the same. So you see that the chemical equation, so that is how you get the information. So let us see how can you get an information about the characteristics or the properties of a element that is involved in the chemical reaction. Is it in a gaseous state, liquid state, solid state, or in the form of a precipitate is nothing but again in a solid state. So if you look at this, the substance is present in the solution of the water. The word aqueous is written. Okay, as I told you in the previous chapter also, aqueous, whenever AQ is written in the bracket of that, that means it's a solution in water. It's a water solution. So we have, so in this, that is in solid state. Okay. Aluminium. Now, heat is liberated in exothermic reactions, and heat is absorbed, not observed is by mistake written into it. It's absorbed. Heat is absorbed in endothermic reaction. During endothermic reaction, you have to heat the product. So carbon and oxygen together give rise to carbon dioxide plus Q. Q is nothing but heat. You know, the delta sign, whenever it is given in the reaction, that means the reaction has to be heated up. And in the product, you know, if heat is released, it is an exothermic reaction. If heat is required, it's an endothermic reaction. It absorbs heat. So Q is the heat energy with plus sign on the product side for exothermic and minus sign on the product side as endothermic reaction. So looking at the equation, you can easily say that whether it's an endothermic or an exothermic reaction. I'm still waiting for your answers on respiration and photosynthesis. If a gas is evolved in the reaction, it is denoted by an up arrow. That was also explained to you. Whenever hydrogen gas, oxygen gas, or carbon dioxide is released, gas is liberated, you get an up arrow. If gas is not liberated, it will be written in G in the form of a bracket. Now in zinc and sulfuric acid reaction, we get zinc sulfate plus hydrogen gas. So hydrogen gas is liberated here, and it's an endothermic reaction, so we have to heat it. And if you look at silver nitrate, what are we doing? Silver nitrate and sodium chloride combine together to give you the silver chloride plus sodium nitrate. Okay, so here say you get a precipitate. So sometimes the reaction conditions such as temperature, pressure, catalyst, etc. are indicated above and below the arrows in the equation. So what happens is, you know, this temperature, pressure, they are all, when you do a science project, you know that there are variables. So these are the constant variables which does not take any part, like catalyst. There is something called catalyst, some certain times magnesium is used as a catalyst in the reaction. So what does catalyst do? Catalyst enhances the rate of reaction without itself undergoing any change. And temperature as well as the pressure are also one of the important factor that causes changes in the reactions that could make the reactions, I mean, slower or quicker depending upon these conditions. Time taken to take for the reaction to complete depends upon these variables also, that is temperature. We call it STP. So pressure and temperature. So six molecules of carbon dioxide plus 6 molecules of water, when they are combining together, they give rise to C6H12O6, your glucose. This is common reaction of your photosynthesis, and 6 molecules of oxygen. Now let us see whether it's a balanced equation. What have we done? We have taken 4 hydrogens and 2 molecules of oxygen, and it gave rise to 2 molecules of water, and it's a very balanced equation. We have got 4 in reactants and 4 in this products, and same with oxygen. Now the molecular masses, how are we going to express the relative masses of the reactants and the products, and what is the unit by which we are measuring? Okay, so the masses are expressed in grams. You have seen a common balance in your lab where you can measure how many grams of reactants are used and how many grams of products. You can measure them and check that they are always same. The mass can neither be created nor be destroyed. At given condition of temperature and pressure, using molecular mass volume relationship, it can only change the rate of reaction. If you look at the molecular mass of water, water is H2O. 2 into 1 plus 1 into 16 is 18. Hydrogen is 1 and oxygen is 16. So the molecular weight of water has to be 18. So mass and volume relationship is how is being maintained like this. Okay. Now in this example, it's explained. If you look at aluminium, aluminum is in a solid state, and ferrous oxide is also in a solid state. And when these atomic masses, let us see the atomic mass of aluminum. Aluminum is 20, we are 27 unit. You have seen the weight. It's written in your periodic table, the weights of all the elements. You can check it with that. So atomic mass of aluminum is 27. And these are few of the common examples. You have to remember the mass of these elements if you get these problems in your exam. And iron is 56 unit, oxygen is 16. So now we are taking 2 molecules of aluminum, and ferrous is also 2 and oxygen is 3. So now what are we doing is 27, aluminum is 27, 2 into 27 units plus ferrous is 56. So 2 molecules of ferrous, 2 into 56 plus 3 molecules of oxygen. Oxygen is 16, 3 into 16 units. And then the products which we are getting is same. So when you calculate these mass, you find that both the masses on the left hand side and the right hand side has to be same. Okay. So, and then 2 molecules and 1 molecules, and even the molecules remains the same. So 54 grams per 1 plus 160 grams are the reactants, and in the products also we are getting 102 grams plus 112 grams. So react with the weight on the left hand side and the right hand side is one and the same. So you can prove this law of conservation of mass uh, in your lab using the common way balance. So calculate the amount of aluminum required to get 1120 kg of iron by the above reaction. If we require 1120 kg of iron, then how many units of aluminum has to be taken? Now if you balance this equation, what are we doing is 54 grams of aluminum, and we are taking 112 grams of iron. And how are we going to multiply? We just wanted to know how much of aluminum is required to have 120 kg of iron. So this we are taking as x, and we have to find out how much aluminum is required. So by doing this, we calculations do this calculation is very simple, you can do it. We came to know that we require 540 kgs of aluminum to get that much of iron. So calculate the volume, mass, and number of molecules of hydrogen liberated, and when it reacts in the when 230 grams of sodium reacts with the excess of water at STP. So what are we doing is we are taking 2 molecules of sodium in a solid state plus 2 molecules of water in a liquid state, which give rise to sodium hydroxide, which is an aqueous solution, plus hydrogen gas is released. Now, if you look at the weights of it, sodium is 23 grams, 2 into 23 units, plus water, 2 hydrogen is 1, 2 into 1, its mass is 1 unit, and plus oxygen is 16, so 1 into 16 unit. This is giving rise to 2 into 23 plus 16 plus 1 plus 2 into 1. That means 46 unit plus 36 unit is giving rise to 80 units plus 2 units, or 46 grams of sodium plus 36 grams of water give rise to 80 grams of sodium hydroxide and 2 grams of water. So it's a balanced equation. So 46 grams of sodium gives 2 grams of hydrogen. So 230 grams of sodium gives how many grams of hydrogen? A simple equation. Now you can even change these numbers and see how much is required. So these are the simple equations given in your textbook. Solve all those equations, and they are very simple. Using these equations, you will be able to solving these problems. You can score 10% marks. 1 gram of molecular mass of any gas at STP, the standard temperature and pressure, that is to 273 K, and standard pressure is 1 bar, occupies 22.4 liters, known as the gram molar volume. So 22.2 grams of hydrogen occupies 22.4 liters at STP, whenever at the standard temperature and pressure. And 10, these are the standards. 10 grams of hydrogen occupies how many liters of STP? If we have to calculate, we have to use this formula, and we could calculate and find out that 112 liters. So 2 grams of hydrogen, you have to double how many it will give rise to it. So the 1 mole of hydrogen contains 6.02 into 10 to the power of 23 molecules of 10 grams of hydrogen contains. So now 6.02 into 10.23 to the power of 23 is what is your standard molecular weight that has been derived. So when you are using, so in this question, what we have to do is, so 30 into 10 into 10 to the power of 23 molecules gives rise to 3.01 into 10 into 20 power of 24 molecules of this. So with this, we end your chapter on chemical equations. Hope you have understood. I have gone in detail. Take your own time and see the video in parts or as per your convenience, as you are understanding. Do it, solve, try to balance the equations, solve the problems, and try solving all the problems that are given into your book, as many as possible. Or you select some more problems, you only design your own problems, or if you want me to give, I'll also give you, but make sure that you do it wonderfully well. Take care, stay safe, follow SMS rule. SMS rule is, what is SMS rule? You all know that you have to maintain social distancing, wear your mask, use sanitizer. Take care. Allah Hafiz.